Alright, you know there has to be a shorter way to do these electron configurations, so let's have a look. So a quick look at orbitals again, just because we know that it's still pretty new and fresh. Alright, here's the periodic table. It's organized into the S block, which is full of S orbitals. All of the S orbitals are spheres. Each one, as you move down the rows, each one getting larger than the one that preceded it. Each one can hold 2 electrons. Then we move to the P block. It starts in the second row. The P block is filled with P orbitals. Each row of the P block contains 3 P orbitals. Each P orbital can hold 2 electrons for a total of 6 more electrons per row. From there we move to the D block, which is filled with D orbitals. The D orbitals, remember, have funnier looking shapes. Alright, there's 5 D orbitals per row, 2 each, so a total of 10 electrons. Right, from there we move to the F block. F block is filled with F orbitals. F orbitals are quite complex in shape and nature. 7 orbitals per row and a total of 14 electrons, 2 each. Alright, let's have a look at the shortcut. Take a moment and try to write the electron configuration for calcium, and then take a moment and try to write the electron configuration for argon. Now hopefully you've come away with both of these electron configurations from 1s2 out to 4s2 and 1s2 out to 3p6. Now what I hope you can realize, or hope you can see, is that the electron configuration for argon actually sits inside the electron configuration for calcium, which we see here highlighted in blue. So what we often do is we call this the noble gas shorthand, and we essentially use the noble gas as a reference point, and rather than write the entire electron configuration for calcium as was written in black, I would write Ar, the symbol for argon, in square brackets, and then 4s2, so everything that comes after argon. Alright, this will allow me to save quite a bit of time if I'm doing some of the larger ones. So, find the element, find the noble gas that precedes it on the periodic table, write the noble gas symbol in square brackets, and then the terms coming after it. Alright, so the example I'm going to use here, and sorry for the fact that it's so small, but is write the full electron configuration for Am. It's americium. Alright, so this is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d1, 4f14, 5d9, remember the d1 and the d9 add up to d10, 6p6, 7s2, 6d1, 5f, count out in the F block now to Am, americium, what I have circled in blue, so this should be 5f6. Now, at this point, notice the 6p6 would be the electron configuration of radon, so I'm going to put Rn in square brackets, then I'm going to write everything that came after radon, so 7s2, 6d1, 5f6, much simpler.